Hello my dear students, welcome back to NEET World. So this is our session 2 on equilibrium chapter, right? So in the last session we have covered PYQs related to NEET and EAPCET exams, right? So in this session also we will be continuing our discussion on the PYQs of equilibrium from both NEET and EAPCET exam, okay? Right. So let's begin or let's continue the discussion for the last class here. So in the last class we have solved all these questions. If you see, all these are NEET questions, right? So these are the questions we have solved, all these questions. Yeah, if you haven't watched it, please go and watch it once after completing this session, okay? Right. Now look at this. Today we will be more solving more questions related to ionic equilibrium, okay? In the last class we have solved from chemical equilibrium and also few questions from ionic. Right. So here today we will be more focusing on ionic equilibrium. Just look at this question once. Yeah. So just solve this question once. What will be your answer for this question? See what they are saying, pKb of dimethylamine. See, dimethylamine is a base, okay, and here acetic acid, it's a acid, right? Now it's a weak base, it's a weak acid. Now these are mixed, okay, so weak base and weak acid are mixed, so neutralization taking place right now. So to this, correct option for the pH of the salt formed. See, an acid base react to form salt plus water, like that we know. Okay, so when this dimethylamine and acetic acid are combined, we are going to get the dimethyl ammonium acetate. This is a salt formed. Now what is the pH of this salt solution formed here, they are asking. So whenever we are mixing acid and base, like weak acid and weak base, just use this formula. So pH is equals to 7 plus half into pKa minus pKb. Okay, like this you can take. Okay, right. So from this you are going to get your pH value. Okay, right. So now look at this. Sir, how do we got this final formula? Is there is a derivation I have explained during the discussion of equilibrium, especially ionic equilibrium. If you want to get that complete derivation, you just go through the previous playlist of equilibrium chapter. Okay, right. So now just substitute the values over here. So what we have, pH is equals to 7 plus half into, what is the pKa value mentioned? pKb of dimethylamine is this much, and where pKa is that much. So it is 4.77 minus what is it? 3.27. So now what is the value here? We are going to get 7 plus something, that is 7 plus half into this is 0, 7 minus 2 is 5.1. Okay, so how much it is? 7 plus 1.5 means it is 0.75. That's it now, right? So it will be how much now? 7.75 is the pH of this resultant solution, right? Yes. So hope the discussion is clear. Yes. Is there any confusion? No, right? So option B is your perfect answer for this. Okay, then next here, solve this question. Which among the salt solution is basic in nature? Which of them are basic in nature, they are asking. So how can you solve that? What they are saying? Which among the following salt solution is basic in nature? See, we know a salt is formed by mixture of acid and base. So it will be give you salt plus water. Okay, now if I say a strong acid and a weak base is combined, what I am saying is strong acid, weak base we are combining. So the resultant solution will be also formed, salt will be formed. But the salt solution will be having the nature which is strong. It means salt formed here by combination of these, the salt solution will have the same nature as the one which is strong electrolyte here. Which is strong electrolyte? See, this is a weak base, strong acid I am taking. The salt solution of this strong acid plus weak base will be there now. It has the nature as like that a strong one. Sir, if both of them are strong, it will be a neutral solution. But if I am taking one strong electrolyte and a weak electrolyte, it means let us say strong acid and a weak base is taken. The salt formed here will, the salt solution here if we take, that salt solution will have the nature as like acidic, because here strong acid is taken, right, and weak base is taken. Now in the reverse manner if I take, here I am taking weak acid, strong base. Okay, now the salt solution, like we are going to get a salt now, right now. So to this, let us add some water and let us make it a salt solution. So the salt solution will be having which type of nature, tell me? Strong base. Which is strong here? Base is strong now. So the resultant salt solution will be basic. Okay, I hope you got some clarity. Now look at this. What they are saying, among the following, the salt solution is basic in nature. So which is basic in nature? It should be a salt that must be formed from strong base and a weak acid. So now here you can see ammonium sulfate. See ammonium sulfate. See sulfate comes from sulfuric acid.
Yes, which is strong.
Ammonium comes from ammonium hydroxide. See, it's a weak base plus strong acid. No, this is not a acidic salt solution. It's not a basic salt solution. It is a acidic because strong acid is used here.
Yes.
Now this one you tell me, ammonium nitrate. Again nitrate means it should be coming from nitric acid, right now, nitrate ion. So it is also strong. No, strong acid it is. Okay, so this solution will be acidic. Now tell me this one. Sodium acetate. Yeah, sodium comes from, see always cation comes from base. So sodium means, let us say sodium hydroxide is there, NaOH. It's a strong base. Acetate, anion comes from acid. Acetate means acetic acid. Right now. So weak acid, strong base. Yeah, so this resultant salt solution will be no basic. So and pH of the salt solution will be greater than 7 at 25 degrees Celsius. So what is our perfect answer for this? C. Okay, now tell me what will be the scenario in D, option D case? Huh? Yeah, ammonium chloride. So ammonium chloride, see chloride, anion comes from acid. So like HCl. Okay, ammonium cation comes from base like NH4OH. So now which is weak, which is strong? See, this is strong acid. The resultant salt solution, if I take the salt solution of this ammonium chloride, it will be acidic because strong acid is used here. So it will be acidic solution. Do you got? Yes. The salt formed by a weak electrolyte and strong electrolyte is there now. So that salt solution will have the nature same like the stronger one, stronger electrolyte one. Okay, is this clear? Yes. Right. Next. Now tell me here. What is the pH of the resulting solution when equal volumes of 0.1 molar NaOH and 0.01 molar HCl are mixed? Yeah, so those who are watching this live session, if you have any confusion, please mention in the chat box. We will discuss once again. And if there is no confusion, please click on the like button so that I will confirm you are following the session. Yeah, so tell me what is the pH of resulting solution when in equal volumes of NaOH? See, NaOH is a base and HCl is an acid. So now tell me what happens when acid and a base is added? Neutralization takes place. Right now, if they are equal amount, neutralization takes place. But if one is excess, one is less, means that excess one decides the nature of the solution. See, which is greater here? Equal volumes is fine. But here concentration, see, it is 0.1. This is 0.01. So it means concentration of NaOH is more. It means quantity of NaOH is more. So the resultant solution will be acidic or basic? Basic, because NaOH quantity is more. So now resultant concentration of NaOH, that is basic, OH minus is equals to, like you can use this formula, N1V1 or N into V of base minus N into V of acid. Why we are taking N into V of base minus acid? Because base quantity is more now. So that's it. So by total volume here we are taking V total. Okay. So now tell me what is the concentration of base given? 0.1. And its volume they are saying equal volumes. Let us say volume of base is V, then volume of acid also V. So 0.1 into V minus 0.01 into V and V plus V, that is 2V in the denominator. Okay, do you got what I am taking here? Yeah, so this V get cancelled. Next, what we have now? 0.1 minus 0.01 by 2. So what you can write? See, 0.1 means like this you can take 0.01 means, so here you can take 10, so 9, so it means 0.09 by 2. Okay, this is what you are going to write. Okay, I can write this as 9 by 2 into 10 power minus 2, so this will be 4.5. Okay, so what is the concentration of OH minus we got? 4.5 into 10 power minus 2. Now what they are asking, pH of the resultant solution. What we got here, OH minus concentration. No? So now if OH minus is this much, then calculate from it POH. Okay, so POH is how much it will be? POH equals to minus log of concentration of OH minus. So how much it is? Minus log of 4.5 into 10 power minus 2. So this will be, POH will be 2 minus log 4.5. Okay, so 2 minus something we got.
Yes.
Okay, now what about pH?
pH equal to 14 minus.
pH plus POH equals to 14 at 25 degrees Celsius. Now I want pH. So pH will be 14 minus POH. So 14 minus POH is, that is nothing but 2 minus log 4.5. Okay, so this one is how much? 12 plus log 4.5. Okay, now see 12 plus something. So where do we have 12 plus something? Yes, here. Only option D we have like that, 12 plus 4.65. See, do not worry about log 4.5 exact value. So without knowing all that also, we have solved it. Okay, is this clear how we are doing? Okay, right. So try to choose the simplest way possible. Do not get confused with the taking complex steps. Okay, see here the same thing can be solved in a different manner also. Concentration of OH is this much now. See, product of, see, when water is undergoing dissociation, what we are going to get? H plus and OH minus. Now the concentration of H plus into concentration of OH minus, that is ionic product of water is there now, that is equals to 10 power minus 14. Okay, so from this already I have OH minus ion concentration this much. So now if I want to get H plus ion concentration, 10 power minus 14 by OH minus ion concentration in the denominator, that is 10 power minus 14 by 4.5 into 10 power minus 2. So this also upon simplification you are going to get H plus ion, from that you can get pH. Okay, these are the two ways you can do the question. Okay, easy. Next, let's move forward. Yeah, tell me again, which are the following salt will give highest pH in the water? Tell me, it is also easy. Which are the following salt will give you highest pH in the water? So see, it means these are the salts they are saying, and you just place them in the water. What happens? We are going to get here Na plus and Cl minus ion, because it's a strong electrolyte. It will give this thing only. Like if I say NaOH and HCl, OH and H plus combine to give water only. So it will not undergo hydrolysis. It's a neutral solution. Okay, so its pH will be now 7 only. Neutral means. Okay. Now copper sulfate if you take, if I hydrolyze this, what I am going to get here? What I am going to get? CuOH twice plus sulfate ions are there. It is going to give you H2SO4. Sulfuric acid is formed. So pH of the sulfuric acid will be definitely less than 7 because acidic, strong acid. Similarly, if I take this NaOH plus carbonic acid H2CO3. How many NaOH we are going to get? 2. Okay. So definitely this is pH greater than 7. Here also you are going to get KOH plus HCl. See, it's a strong electrolyte now. It's a neutralization takes place. So here you are going to get only K plus and Cl minus ions. Okay, this is also neutral. So pH of this solution is 7. So what will be the perfect answer where you are seeing highest value? Na2CO3. The highest one is for Na2CO3, B. And least one is for which one? pH is the least for which one?
C.
Copper sulfate solution. Like this you can go for the answers. Okay, right. Let's move forward. Tell me for this. Okay, we already did this. Next, this one. What they are saying? Read the question once. Read the question once again. They are saying ionization constant for ammonium hydroxide is this much. The hydrolysis constant of ammonium chloride. It means ionization constant. It means Kb of this salt is given as a base is given as a some value is given, and they are asking about Kh. Okay, Kh hydrolysis constant they are asking. Okay. So Kh is equals to Ch square will get. How do we got this? I will tell you. Okay, so from this Kh we do not have H. Okay, so next one is Ka into Kb is equals to Kw we can write. Okay, so from this what they are asking, ionization constant of ammonium hydroxide is given, hydrolysis constant Kh value they are asking now. Okay, just a minute, we will come back to this because we need to look for derivation of this. Okay, if just solve this question once. What they are saying, what is the OH minus ion in the final solution prepared by mixing 20 ml of 0.05 HCl and 30 ml of 0.1 molar barium hydroxide? Tell me, what is this? HCl is an acid, BaOH twice is a base. First of all, find its N factor. What is the N factor for this? 2 OH minus ions are there now. So you should use the formula like, see, acid and base neutralization now. So now N resultant you need to find. What is that resultant formula?
Sir, we can't take N1, V1.
Yes, that not plus here, minus you need to take. Why? Base and acid are there now, neutralization. But which one concentration is more here?
0.1.
Mixing 20 ml of 0.05 molar HCl. Okay, so otherwise you just take mod of this. It means you are going to take only positive value. Okay, here in the denominator V total you are going to get. Okay, so now tell me what I should take here in the numerator.
0.1.
Yeah, N into V of acid minus N into V of base you take, acid and base. Here V1 plus V2, V1 that is acid plus base you take. Okay, now try it and tell me. In the comment box, Shivani Yadav, nice sir. Shruti, good evening. Good evening, Shruti. So just follow the session. If you have any confusion, please ask me. Try to solve the question. What is the answer? So tell me, end resultant, what you will do? What is the final volume we got? 50. 30 plus 20 is 50 here. And what about this thing? For acid, what is the quantities mentioned? HCl. Solution prepared by 20 into 0. For molarity, normality for mono basic acid is same. Okay, n factor is 1, that's why. Okay, minus 30 into volume is 30 and its n factor is how much? 2. So molarity, normality, what is the relation? 2 into like valency factor into molarity is what? Normality we are writing. So 2 into 0.1, that is 0.2. So here it is 0.2. Now what we got finally? 50 in the denominator. So here see, I can write 0.5, 0.52 is a 1 and this is 6. 6 minus 1, 5. So mod is there now, so you can simply write it as 5. 1 by 10, that is 10 power minus 1 or 0.1. Okay. So now what we got is its solution is basic or acidic. Tell me which quantity is more. Here it is a 6, here it is 1. So which quantity is more? 6. Basic. So the end resultant, this is nothing but OH minus ion concentration. Okay. If we got OH minus ion concentration, they are asking about what? What is the OH minus ion concentration? That's it, over. What is the OH minus ion concentration we got?
0.
So fourth option. Okay. If they ask for pH of the same question, they are asking for pH of the same question. Minus log 10 power
-1.
that is POH you are get. You are going to get POH. So from that you can say pH is equals to 14 minus 1. See, 10 power minus 1 means POH will be 1. pH will be 14 minus 1, 13. Okay, like that. Next, this one you tell me. Do these ones. So just try it and tell me what is the answer. So tell me what you will do. Equal volumes of 3 acids. Like these are the pHs of 3 acids they have given. What is that? pH is equals to 3, 4, 5 for 3 different acids. Okay. Mixed in a vessel. It means volume of all those solutions will be no same. Okay. Now what will be the H plus ion concentration in the mixture? Okay. It's very simple. We are going to do we are going to find equal volume. What will be the concentration of H plus they are asking. This is what they are asking for the mixture. Okay. It means whenever I say pH equals to some X, what I am saying, pH equals to some X. Okay. Then pH equals to X means then concentration of H plus should be taken as 10 power minus X. It means, for example, I am saying concentration of H plus is equal to 10 power minus 3. Now what is the pH value I am asking?
3.
So how you are saying this? Because pH is equals to minus log concentration of H plus, right? So H plus ion is how much concentration? 10 power minus 3. So now just substitute here minus log 10 power minus 3. So pH will be now minus 3, you can write here plus 3. So 3. So here whatever the number you are saying, that will be the pH. So if concentration of H plus is 10 power minus x, then pH will be x. So now here see, for a solution like for an acid one, what is the pH we have? 3. So it means its concentration of H plus ion will be how much now? For acid 1 it is 10 power minus 3. For acid 2 it is 10 power minus 4. For acid 3 it will be 10 power minus 5. That's it. These are the things you need to do. Okay. Up to here it is clear. The next one is, I want a total H plus resultant total H plus ion concentration. Now what we know, N1 V1 plus N2 V2 plus, that is what we need to do. If I mixing two different acids, let us say having concentration N1, volume V1, N2 and V2. So the next N resultant will be N1 V1 plus N2 V2 by V total I should use. So here also I have H plus ion, total H plus ion concentration will be resultant equals to 10 power minus 3. Let us say its volume is V. Okay. Equal volumes they are saying. Let us say volume V, and this is also 10 power minus 4 into V. Okay, plus 10 power minus 5 into V. So total how many V's now? V1 plus V plus V plus V, 3 V's. Okay, so all these V's can be removed now. So now what I can write this one as, see 10 which is bigger number here, 10 power minus 3. 10 power minus 3 is bigger number. Okay, so now 1 plus, I am taking that number as common. So this 10 power minus 4 is there now, you can write it as 0.1 into 10 power minus 3. Okay, that is 0.1 I am writing here. 10 power minus 5 you can write 0.01 into 10 power minus 3. Okay, it means here 0.01. So now by 3. So now 1 plus 0.1, 1.11. 1.11 by 3 into 10 power minus 3. Okay, so this is what we got till now. Okay, what they are asking, what will be the H plus ion concentration in the mixture. Okay, we got up to here, right. Let's check for other things. Yeah, up to here it is fine. Now what I am writing here, 11.1 into 10 power minus 4 by 3 I am writing. Okay, so try to cancel out it. 3 3s are 9. 21 is there, 7. So what is the answer? 3.7 into 10 power minus 4 is a resultant H plus ion concentration. So do we have any option like that? C. That will be the perfect answer. See, you have a trap here, 1.1 into 10 power 3. You might be seeing like this might be the incorrect way of doing. No. Go through the further steps, you will get the exact answer. So C is the best answer for this. Okay, right. Let's go for the next question. Yeah, so the next question here is, tell me what will be your answer for this? What is that question says here? pH of solution containing 50 ml of each 0.1 molar acetate and 0.01 molar acetic acid. Yeah, so first of all, this is a concept called buffer solution. First of all, let's understand theory, then we'll come back to this. Wait for some time. Okay. Buffer solution questions we required now. Yeah, let's come back. Otherwise, let me explain it. We'll go to the next further questions. Just listen what I am saying. Buffer solutions means, see, buffer solution means it is a combination of a weak electrolyte. It means it should be a weak acid or a weak base. What I am saying, buffer solution is a combination of weak acid. You can, first of all, let us discuss about weak acid. Okay, so this is called acidic buffer. What I am talking, that is about acidic buffer. Okay, so now what is this buffer will do, I will tell you. First of all listen. So weak acid plus salt of that weak acid, it means weak acid plus strong base I am adding. Okay, what we are going to get now? For example, weak acid is acetic acid is the best example you are familiar with. Okay, and NaOH is stronger base. Okay, now what happens between them? Neutralization takes place. If I say 191 mole, so OH minus H plus water removed and sodium acetate is formed, H2O. Okay, so this is what forms if I take equal amounts. But tell me what happens, I am taking excess quantity of acetic acid. Let us say 2 moles of acetic acid, 1 mole of ammonium hydroxide I have taken. Now what is the resultant mixture will form? Which is excess? Acetic acid. How many moles we have? But for reaction how many moles is enough? 1 mole is enough because NaOH is 1 mole. So out of these 2 moles, 1 mole will react with this NaOH, remaining 1 mole remains excess, right now. So now after reaction what we are going to get? We are going to get 1 mole of acetic acid solution, this one, and this is 0 mole of NaOH and 1 mole of sodium acetate. Okay, this is what the resultant mixture we have, right now, this one and this one. Okay, it means this resultant mixture we got now, this is called acidic buffer. See, it means what you got to know, acidic buffer means it is a combination of weak acid plus the salt of that weak acid with a strong base. Okay, see, it's a combination of weak acid plus the salt of this weak acid with a strong base. So this mixture is called what? Acidic buffer. In order to make or in order to prepare acidic buffer, what should be the thing to be taken in the excess quantity? Weak acid should be excess quantity. Take limited quantity of strong base. That resultant mixture will be forming a acidic buffer. So now what is the use of buffer actually? Yes, you can use buffers. Like see, in the biological system itself we have very good application. See, you will be taking lemon water, na? Some acidic juices you are taking.
Yes.
Lemon water, normally lemon water, what happens when you squeeze the lemon water in the lemon juice in the water? Water is neutral, but when you squeeze the lemon, water becomes acidic because of lemon juice, right now. Now that same lemon juice you are drinking, you are taking, okay, but the pH of your body is not altering, right now. Is it changing? No, it is being constant only. Why it is not happening with the simple water? Why it is happening? Why it is only in your body? Because your body contains some solutions called buffer solutions. Okay, so that buffer solution will resist the change in pH by addition of small amounts of strong acids or bases. Means what is the duty of buffer solutions? It will resist the change in pH by addition of small amounts of acids or bases. Okay, if pH of body changes, what happens? The body won't function properly, right now. So, but that's why there are some system in the body by nature, it is resisting the pH to do not alter when we take in small amount of acids or bases. Again I am saying small amounts. If you take larger amounts, yeah, there will be definitely some effect, right now. So this is the importance of buffer solution. Okay, right. So acidic buffer you got now. Now they will ask you, how can you calculate the pH of this acidic buffer? Okay, so the pH of this acidic buffer can be calculated. Again, the derivations of this I have already discussed. Okay, pKa plus log concentration of salt. Salt means this is salt only, na? Salt by acid, that is acid there. Okay, this is what you need to know. This is the story about acidic buffer. Again tell me, what is the mixture of acidic buffer?
Weak acid
So, weak acid plus salt of that weak acid with a strong base. In the same way, you tell me what is the mixture for basic buffer. What is the mixture, I mean combination of basic buffer, like this. See, for weak acid it is a weak acid. For weak buffer, acidic buffer we have this one. Now for basic buffer it should be a weak base plus salt of this weak base with a strong acid. Now give an example. NH4OH plus HCl is a strong acid. So NH4OH plus HCl. What you are going to get? NH4Cl. So this combination is called basic buffer. Example of basic buffer. So now for basic buffers, we need to calculate POH. What is the formula for POH? Same. Here for acids we have Ka, acid dissociation constant. For bases we have Kb. So here you should take pKb plus log concentration of salt by concentration of base. Okay? Yeah. So for offline students, you people, whatever the notes I have shared today in the group, you just go through that. Everything is given. Okay? Anyways, your class notes are also there. You can go any of those. Okay? These are the two things you need to use. Now tell me, what will be your answer for the question? For this question? pH of the solution containing 50 ml of each 0.1 molar sodium acetate and 0.01 molar acetic acid. Tell me, how can we do this? Easy. pH is equals to acidic buffer or basic buffer. First of all, acidic buffer. Acetic acid is there means acidic buffer. So you should take pKa plus log salt concentration by acid concentration. pH is equals to pKa. pKa value they mentioned 4.57 plus log, what is the salt concentration they have given? See, 50 ml of each. It means volume of that solutions are same. Okay, so that is 0.01 molar sodium acetate. So it means I can say 0.1 molar salt. Sodium acetate is a salt. And acid is how much? 0.01. So how much it is? pH is equals to 4.57 plus this one is 10 times now? Yeah. So 10 times means sorry. This one 0.01 means above 1 is greater. So it is 10 here. So log 10 is 1. Okay. So how much it will be now? 4.57 plus 1, 5.57. So what is the pH of the resultant solution? 5.57. So we have option B. Okay, do you got how we are doing? Yeah, right. So I hope you got what are the formulas to be used here. For acidic buffer,
pH equal to pKa plus log salt by acid.
For basic buffer,
pH equal to pKb.
POH
equals
to pKb plus log.
salt by base.
That's it. Now for see, there is something called salt buffer. So in the case of salt buffer, what is the formula of pH to be used? Tell me. This is nothing but combination of salt buffer is formed by combination of weak acid plus weak base. So pH you can use 7 plus half pKa minus pKb. That's it. Okay, these are the things to be remembered here. Okay, right. Let's move forward. Yeah, try this question now. This is solubility based question now. We'll again come back to solubilities. Let me show you few more questions related to buffer. Yeah, let me show some questions. Find this. pH of 10 liters of buffer solution containing salt and this one. Do this. It's easy. Just try this. First of all, identify basic buffer or acidic buffer. Do that. Write fast. Okay, tell me. Yeah, how can you solve this? What is the pH of 10 liter of buffer solution? Means volume is 10 liter, that is fixed. Okay, buffer solution containing 0.01 molar salt plus base, weak base. So now what we need to find, it's a basic buffer or acidic buffer? Basic buffer. So find pOH. Okay. Yeah, Shruti, you are saying 5. Yeah, let's try this. So pOH equals to pKb plus log concentration of salt by base. Okay, so pKb is how much mentioned? 5. So 5 plus log
0.01.
Salt concentration is how much? Salt, this one 0.01. Sorry. This one is how much? Base 0.1. So this is denominator is greater, so 10 times. So 1 by 10 we got. Okay. So you can write denominator 10 like in the numerator 10 power minus 1. So 5 plus log 10 power minus 1 we can write. So this is 5 minus 1. Because this power I can write minus 1, log 10 is 1. So it is minus. pOH is equals to how much? 4. Yeah. So what I want? pH. Question is asking about pH. Okay. So now pH plus pOH is how much? 14. Okay. Then pH is equals to 14 minus 4. That is 10. So what is your answer for the question? 10. Option C is your correct. It's the correct answer. Okay. So Shruti, in the comment you are saying 5, but it is 10. Multiply with 2. Okay, right. So I hope you got some clarity now from the discussion. Okay, let's go to the previous question. Yeah, we have a lot of questions here anyways to practice. Yeah, those who are in the online session, please take a screenshot of this and you just mention your answers by mentioning the time slot so that I can verify your answers for these questions. Yeah, so go back 25. Yeah, so this is about basic buffer and acidic buffer concept. You got some clarity now. Okay, right. The next one is solubility and solubility product. Okay, let me explain this solubility and solubility product formula based questions once. See, if there is a salt like AXBY, okay, now this salt can be considered to be sparingly soluble salt. What I am saying? It means this salt, whatever the quantity you are taking, it's no matter, but it will dissolve only to some extent in the water. Okay, it means we need to consider the ion concentration depending on the amount of salt that is soluble in the water. That's it now. Okay, let us say I am placing this in the water. Now what happens, some quantity I am saying it is soluble in the water. So now that whatever the quantity dissolved, that will dissociates like A and B. How many A's are there? X A's. Let us say first number as cation, the second one as anion. So Y B's are there. Since cation I am saying it should be plus, anion I am saying minus. Okay. Now since it is a neutral, so what I should take here? Minus X. That's it. Overall will be neutral upon multiplication. Okay, because what is the multiplied number here? X into Y, there also Y into X, number total number same, so it is neutral sum. Okay, right. So now I am saying only some quantity dissolved now, yet initially there is no salt ions here. Okay, after some time equilibrium is attained, so at that case you are seeing quantity of this A ions dissolved is, let us say, indicated with S. Okay, how many ions are there? X. Similarly Ys. Okay, now the solubility product of these ions, it means what is the quantity of these ions are dissolved now, what are the concentration? Xs, Ys. So what is this? S indicates amount, the concentration, that is nothing but molarity of this ion and molarity of this ion present in the water now, because we are dissolving this in the water now, like that you can consider. Now the product of those two ions concentration is considered to be solubility product. Okay, now I can write what is the ion we have? A ion as well as B ion. Okay, now what are the stoichiometric coefficient here? So write the power to that ion. Okay, for this Y, like this. Okay, that's it. So now what is its concentration here we have after dissolving? Xs to the power X, here Ys to the power Y. Now what you can write? X power X, S power X, Y power Y, S power Y. So I can simply write X power X, Y power Y, S power X plus Y. Okay, so this is a KSP formula. So why I have given this? Yeah, it will be useful because it's a generalized formula. Now I will tell you with one example so that you can easily understand. Ag2CO3 I have. Okay, how this salt will dissociate, tell me? 2Ag plus CO3 minus itself is 1 ion. Okay, considered to be whole as 1 ion. So 1 carbonate ion is there. Now what is the KSP? You can write directly. Formula if I want to get 2 power 2, this is X, like X if you compare the 2 power 2, 1 power 1 and S power 2 plus 1, S cube. So 4S cube is the KSP formula for this. Like this you can use it. Okay, right. Now what happens is, do you remember Le-Chatelier principle? What happens from Le-Chatelier principle? If I increase the concentration of product side, the equilibrium will shift backward. If I increase the concentration of reactant, forward. Okay. So now what happens is, I'm adding to this. I'm adding a strong electrolyte which gives this kind of ions. It means this is the equilibrium state I have. Okay. To this I'm adding Na2CO3. What I'm adding? So Na2CO3 will dissociate to give 2 Na plus and CO3 2 minus. Now what happens? Concentration of carbonate ion increases or decreases? In the solution, increases. So if product concentration is increased, what happens to equilibrium? Backward. See, if it is moving backward means now the ionic product, it means this number of ions previously we have more, but due to increase in the concentration, equilibrium is going backward. So now what happens to Ag plus ion concentration? Decreases, because these two ions are now combining, going back. Going forward, backward means what happens? These two ions are combining and moving backward. So its solubility product or its solubility, the solubility of weak electrolyte decreases upon adding a strong electrolyte which is having common ion with this weak electrolyte. Again, tell me, see, it's a weak electrolyte. It has some solubility. That solubility is indicated with the symbol S. Okay. Now what happens to this solubility when I am adding some quantity of that ions from a strong electrolyte? when I add that ions to this, concentration of ions, that is product concentration, is increasing. Equilibrium will move backward. Therefore, the solubility of the salt decreases. Okay, this is what you need to remember. Okay, right. Let us check one question. Okay. Okay, so try to solve this question. What they are saying? Find out the solubility of NiOH twice. Okay, nickel hydroxide is there. It will dissociate to give Na plus 2 plus 2 OH minus. Okay, so we need to find out the solubility of this salt, this compound in 0.1 molar NaOH. Okay, given the ionic product of NiOH is it means if you do this KSP or KIP here, what is the answer here? They have given ionic product this much, 10 power minus 15. That is the value they have given. This is the story before adding NaOH. Before adding NaOH, this much KIP value is there. Now, to this, what I am adding is, to this electrolyte, to this mixture, I am adding NaOH. Now tell me NaOH, what it will gives you? Na plus and OH minus. See, OH minus ion is coming from NaOH. Now previously we have here 2 OH minus. This is the equilibrium we got. Let us say at time t0, this is S0, 0. After some time t, this is S minus something. This is S, this is 2S. This is the concentration of OH minus we have. To this, what I am adding? I am adding common ion. What is that common ion? NaOH. Now what happens to OH minus ion concentration in the resultant solution? Increases. How much it will become? It will become 2S from this OH minus, and also from here we are getting now OH minus. What is its value mentioned? 0.1. So total OH minus ion concentration is this much, 2S plus 0.1. But what I told you, due to increase in the concentration of OH minus, equilibrium will goes backward. It means this concentration should be now equals to just 0.1 only. It means why I am taking it is equals to 0.1, because concentration of that OH minus ion coming from strong electrolyte will dominates this OH minus ion coming from weak electrolyte. So the value of OH minus is now equals to 0.1 only, which is from strong electrolyte. So now ionic product means, how do you write for this? KSP is equals to, or KEP equals to here, concentration of Ni plus 2 into concentration of OH minus to the power 2. Now I want to get solubility, this one. Okay, so now Ni plus, let us say this is S. What is the OH minus ion concentration? Now here we have 0.1 to the power 2. And what about KEP they have given? 2 into 10 power minus 15. See how much it will become now? This is 10 power minus 1 power 2, that is 10 power minus 2. 2 into 10 power minus 15. So now how many times it is? 10 power minus 13. So S is equals to 2 into 10 power minus 13. So yes, we have an option D. That is your answer for this question. Okay, so S is nothing but molarity. Okay, what is that? Molarity. Okay, let's move forward. Yeah, the next one, I have left one question there now. What is it? Where is it? Yeah, this one. What the question says here? Ionization constant of ammonium hydroxide. It means Kb value is how much they mentioned? 1.77 into 10 power minus 5. Okay, and hydrolysis constant of ammonium chloride. So it means Kh value they are asking ma. So it's very easy, I will tell you, just follow these tips. First of all, what is the concept we are using here? Ammonium, hydrolysis of ammonium chloride It means ammonium chloride, how it will form? Tell me first of all. NH4OH plus HCl. This is the combination. It gives you NH4Cl plus H2. Okay. Now what happens when you hydrolyze this NH4Cl? We are adding water so that it will undergo hydrolysis. If it is undergoing hydrolysis, you are going to get NH4OH plus HCl. Okay. See, this is a strong electrolyte. Salt is a strong electrolyte. HCl is a strong acid. It is also strong electrolyte. So Cl minus is removed. Now what is the ion we have at the product side? H plus ion. So H plus ion means the resultant solution is acidic or basic?
Acidic.
Yes. So that's why hydrolysis of this salt will be acidic. Okay. So like this. So now what we have here? Base we have. Okay. So now let us say how this base will dissociate. Tell me. Okay. See, this is an equilibrium now. So let us say this is C, this is 0, 0. Okay. Hydrolysis now, C minus CH. H means what? Hydrolysis constant, like degree of hydrolysis I can say, not constant, degree of hydrolysis. Here I can write CH, CH. It means the degree of hydrolysis, the hydrolysis constant. For example, I have there NH4OH now. NH4OH means how it will dissociate ma? Tell me. NH4 plus OH minus. Okay. So now base dissociation constant can be written as concentration of NH4 ion and concentration of OH minus ion by concentration of base NH4OH. This is what? Kb value. Similarly, you tell me for KH, what are the ions here we have? NH4OH. That is H plus ion I am writing. Okay. Here what is the ion we have? NH4 plus and water also we have. So if you want you can write water also here, no issues. Okay, we got Kb, KH, and I am writing, just I am taking water separately now. How this water will dissociate? H plus and OH minus. So ionic product of water means what you will write now? Concentration of H plus ion multiplied with concentration of OH minus. Now try to merge these three things, KW, Ka, KH. See, just to see what I am doing, Kb into KH. What I am taking? Kb into KH. These two I am multiplying. So what is the ion here? These two I am multiplying. What happens? NH4 plus in the numerator, NH4 plus in the denominator. Can I cancel out them? Yes. Next one, NH4OH in the denominator, here in the numerator. Now what are the ions we are remaining with? H plus and OH minus. Okay, H plus and OH minus. Okay, so this is nothing but KW. So now ionic product of water at 25 degrees Celsius is how much? 10 power minus 14. Okay, why this 10 power minus 14? See, if you take one water molecule, it will dissociate like H plus and OH. So water is a neutral component we are saying now. Why? Because when it is undergoing dissociation, you will get equal number of H and OH minus ions. One H plus and one OH minus comes from one water molecule. So now each ion will be having concentration of 10 power minus 7 at 25 degrees Celsius. At 25 degrees Celsius, what is the ion concentration? H plus and OH minus. Both of them have 10 power minus 7, 10 power minus 7. So if I multiply them, what is the value we are going to get? 10 power minus 14. That's why H plus pH, like what I am saying, pH and pOH. Total sum is how much?
14.
Yeah, why we are taking 14? Because here we are getting 10 power minus 14 now. So that 14 you are seeing there. Okay, that, and what is the neutral point you are seeing? At 25 degrees on pH scale. 7 you are saying neutral now, because H plus ion, OH minus ion concentrations are 10 power minus 7. So minus law concentration of H plus is nothing but 10 power. So both of them are equal now, so midpoint is 7. That's why it is neutral here you are saying. Okay, so up to here it is clear. Now Kb value how much they mentioned in the question?
That's
That's it. So KH now what I can write? KW by Kb. So kW is how much? 10 power minus 14 by kb is how much? 1.77 into 10 power minus 5. Okay, so how can you write this now? This will be 10 power minus 9. Okay, 1 by 1.77 into 10 power minus 9. So this one you just take it as 10 by 1.77 into 10 power minus 10. Right. Look at the options. Do we have anything? Yeah. So there is one option with 10 power minus 10. It means 1.7 5s are. Okay. Like 17 5s are, like that you just take. So you are going to get it is as 5.65 into 10 power minus 10. So option D is your perfect answer for this question. Okay. Is this clear? Right. Okay. Let me give you few questions as homework. So just go through these questions and tell me what are your answers for them. So try this. This is a ratio of solubility of AgCl in the water and also in KCl. Okay, try this. This is a common ion effect. This is normal in water. Okay. The next one. Let me give you homework questions. All these homework questions are from EAPCET. Just try this. This one. Okay, those who are watching live, please take a screenshot and tell me what are your answers for these questions. This one. Okay, and this one. This one. This one. The next. All these are EAPCET questions, and I will tell you the complete answers for these questions were already discussed in this YouTube channel itself. You can watch it. Okay, first you try and give me your answers in the comment box. Yeah, so these are some questions I just wanted to give as homework. Okay, so thanks for watching. Stay connected with NEET World. If you like the content, please click on the follow button and share with your friends. Thank you.